In this video, we're going to take a look at identities and fractions and how we might deal with those. So the question is to write 1 all over x plus 1 by x plus 4 as partial fractions. So they're just asking us to separate it out, and really at the root of it, they're just asking us to find a and b. So I would just focus on trying to find a and b. So what we know is that 1 all over x plus 1 by x plus 4, that it can be written as two separate fractions. So it could be written as a all over x plus 1 plus b all over x plus 4. And again, they're just asking us effectively what's a and what's b. So what I need to do is get the left hand side of the equation to structurally look similar to the right hand side. And if I do that, I take a look, it's one fraction versus two fractions. So the first thing I could do is start to make this a common denominator, or more specifically, a lowest common denominator. How would I do that? Well, just look at what the target is here. So I have a all over x plus 1 already, and I'm going to make it x plus 1 by x plus 4. Now I don't want to change the value of that fraction, I want to keep it the same. And how do I keep it the same? I'm going to multiply top and bottom by x plus 4, because effectively then I am multiplying it by 1, and if I multiply something by 1, it stays the same, no value change. I'm going to do the exact same thing for b, except when I multiply in here, I'm multiplying in by x plus 1. So I'm going to multiply top and bottom by x plus 1, because that's the new addition to it. All of that is going to be equal to our 1 all over x plus 1 by x plus 4. And I'm just going to multiply that out now and write it as one big fraction. So one single fraction, it's going to be all over x plus 1 by x plus 4. That's going to give me ax plus 4a plus bx plus 1b. And all of that is still equal to 1 all over the exact same thing. At this stage, I want to start trying to solve this. So they're both over x plus 1 by x plus 4. In other words, if I want to get rid of that, if I don't want to deal with that anymore, what I can do is start to look at getting rid of it. And how do I get rid of a divide? I'm going to multiply. And I'm going to multiply this side by x plus 1 by x plus 4. And I'm going to multiply this side by x plus 1 by x plus 4. I don't have to write this out, but just know where it's coming from. What will happen is I get doing and undoing. I'm multiplying by x plus 1, I'm undoing, I'm dividing by x plus 1. I'm doing the same thing on this side. I'm multiplying by x plus 1, I'm undoing, I'm dividing by x plus 1. Over here, I am multiplying by x plus 4, I'm doing, and I'm undoing, I'm dividing by x plus 4. On the right hand side, multiplying by x plus 4 is the doing, dividing by x plus 4, the undoing. And so they've dropped out. So try to think about why that works. Really get into the nitty-gritty when you're at this early stage in your algebra, because it'll help later on down the line when things get more difficult. At this stage then, all we're left with is 1 is equal to ax plus 4a plus bx plus b. Now, remember our identities, we can only match up x's with x's, y's with y's, x squareds with x squares, constants with other constants. And if I look on the left hand side, I only have the number 1. I don't have any x's, I don't have any a's or b's. What I will do to help myself out though, is I will add a 0x. And now what I can start to do is say, okay, if this statement is true, if 0 plus x, 0 by x plus 1 is equal to ax plus 4a plus bx plus b, that must mean that 0x happens when I get ax plus bx. If that statement is to work out and be true. The other thing I know is that plus 1, that must come from 4a plus b. And so I've got two mini equations that I can write out. And those are going to be ax plus bx is equal to 0x. I've got x right across the board, so actually I could just write that as a plus b is equal to 0. So what I did there was divided everything through by x. The next thing I'm going to have is 4a plus b, that has to equal to 1. And what I'm going to get if I do that out is, it's not going to change actually, there's nothing that I can do. So I need to solve this. And what I'm looking at right now is two equations with two unknowns. And you should have this in your kind of toolbox of skills from junior cert. This is a simultaneous equation. So two equations with two unknowns is a simultaneous equation. After that then, what do? I need to try and get them to eliminate each other, to drop out or to cross out. And I'm going to do that by taking the yellow equation and I'm going to multiply everything in the yellow equation by minus 1. So I get minus a minus b is equal to 0, because minus 1 by 0 is still 0. I'm still going to have the exact same pink equation because I've done absolutely nothing to change that. I'm now going to add these two equations together. And if you're not sure about what's going on here, go back and take a look at simultaneous equations. There's lots of other videos online that you can have a look at there. If I add those two lines together, I'll get minus a plus 4a and I'll get 3a. I'll get minus b plus b, and that's the doing and undoing, so I get 0 is equal to 1. And if I want to get a on its own, I'm going to divide both sides by a. So a is equal to 1/3. I still have to figure out what b was, because remember they wanted us effectively to figure out what a and b was. So I'm going to take the yellow, the original yellow, and I'm going to say, okay, I now know what a is. I actually know that when I do a plus b, a is actually 1/3. So I get 1/3 plus b is equal to 0. Subtract 1/3 from both sides and I get b is equal to minus 3. And there's my two answers. There's the a and the b, which is what they were looking for. Nothing there is overly complicated. It involves multiple steps and it involves multiple areas of the course. So take your time, go through it again and practice. The main thing here is once you have it understood here, you need to go and try a few questions.